Our galaxy is gravitationally bound with Andromeda and about 50 others. Keep zooming out even further, and we reach the Virgo supercluster, a colossal wall of more than 2,000 galaxies spread out over 100 million light-years. But here's the thing, when you look at this vast cosmic web, a repeating pattern starts to emerge. Galaxies, gas, and dark matter all form these sheets and filaments that wrap around enormous empty gaps. The galaxies seem to stick to the rims of these voids, almost like reflections of light on the surface of soap bubbles.
Section 3. Gravity's unfair tug of war. Now, you might be wondering at this point, if galaxies are shooting through space at millions of kilometers per hour on wild collision courses, shouldn't one of them accidentally shoot into a void every now and then?
Why do the voids stay so incredibly empty? Well, and this brilliantly illustrates the answer, it all comes down to gravity. Gravity dictates that everything with mass attracts every other thing with mass, right? But a cosmic void has almost no mass inside it, so you end up with the massively dense cosmic web of galaxy superclusters on the edges constantly pulling matter outward, while the totally empty center pulls on absolutely nothing. It's literally like a cosmic tug-of-war, where one side isn't even trying to win. Over time, this unequal physics means the voids only get emptier, effectively shoving any wandering galaxies out to the edges.
Section 4. Lonely fireflies of darkness. Yet, despite this overwhelming outward pull, the darkness actually isn't entirely perfect.
There are some very mysterious things hiding deep within the emptiness. Faint tendrils of dark matter penetrate into the voids, kind of like cosmic lichen, creating this miniature echo of the massive scaffolding on the outside. And at the tips of these dark matter tendrils, we find the absolute rarest galaxies we know of, void galaxies. Think of them as lonely fireflies, desperately trying but completely unable to light up the night. Because they're so incredibly isolated, they don't experience the violent collisions and chaotic mergers that galaxies and crowded clusters do. As a result, they are aging in slow motion. They tend to be smaller, bluer, and packed full of untouched cosmic gas, giving birth to new stars in a much slower, much calmer way. In fact, because of this slow-motion aging, void galaxies might end up being the last habitable sanctuaries in our dying universe. Think about it. In 100 trillion years, a desperate alien civilization might just embark on an impossible journey to hide inside a void galaxy simply to stretch their existence just a little bit longer.
Which brings us to Section 5, the fate of the universe. Because unfortunately, even these lonely little sanctuaries aren't safe forever.
Voids are incredibly unique places because they serve as the ultimate stage for the universe's most mysterious force, dark energy. So the crucial point is that while we can't easily observe dark energy inside crowded galaxy clusters, mostly because gravity is just too busy pulling things together, inside the voids, dark energy has absolute free reign. Here, we can visibly see it accelerating cosmic expansion, just blowing up